A, B, and this is C. So this is moved with a velocity Vc. I think this much is what the basic information. Okay, let's carry on. So he's asking what is the determine the angular velocity of the rod bar AB. Keep quiet. Keep quiet. We have to calculate the angular velocity of the rod AB. So what is the length of the rod BC should remain constant. So shall we use constraint equation for that? So let the velocity, how the point B will move. I think this is the most important part of the problem. The point B must move vertically down. Any reason? Because the rod AB is hinged about this point. The rod AB is hinged about this point. And how the rod AB will rotate like this. It will have angular velocity omega 1. I'll write it. So because of that, the linear velocity of point B must be vertically down. I think this is the primary factor in analyzing this problem. This is theta. Okay, this will be theta. This will be theta. And then what is the basic constraint equation? So this angle, let it be say beta. Then rod BC is inextensible. As the rod BC is inextensible, so VC cos beta should be equal to VB sin theta. So we know theta given 30 degrees, beta 60 degrees. So VC is how much? 4 feet. I'll make it meter. It'll be easier. $4 will make it. All this will become meter. Definitely, if you look at, maybe it is some foreign author book where they use feet, everything. We see this will be 4 cos beta cos 60 VB sin 30. (4 meters per second). The velocity of point B of the rod 4 meters. If you know velocity of point B, we know the length. We know this length LAB, or say L1, I'll write it. So with this, what is VB is equal to L1 into omega 1. VB we know 4. L1 is how much? 2. Okay, simple. This one. So what is the most difficult thing is like predicting the velocity of point B. Predicting the velocity of point B is the most difficult thing. Once you get this, okay, otherwise nobody can help you. So how, sir, how do you can say the velocity of point B? Look at the rod AB. It will rotate in this plane perpendicular to plane of paper about an axis passing through point A. So therefore the velocity of point B must be vertically down. Got the idea? So I'll write down the idea of the problem. So the important note, I'll write it. Note.